Chapter 8 Discrete Random Variables. In this tutorial, we will learn how to construct a probability distribution table if we have a probability function, and then to use the property which is the sum of all probabilities add up to 1. Look at this exercise. The random variable capital X has the probability function. Probability of capital X equals to X is equal to X minus 1 over 10. And the X is equal to 1, 2, 3, 4, and 5. Construct a table giving the probability distribution of X. First, we draw the table. Inside the table, we write X, which is the random variable, and corresponding to it, we have the probability. The values of X are 1, 2, 3, 4, 5. Now we should look at the corresponding probability for each value. The probability is X minus 1 over 10 for each value. So we simply need to substitute the X in order to calculate the probability. When X is equal to 1, we have 1 minus 1 over 10. That means 0 over 10, so the answer is 0. When X is 2, 2 minus 1 over 10, the answer is 1 over 10. Then we have 3 minus 1 over 10. The answer is 2 over 10. Here we can simplify or we can leave it like this. Okay, let's move to the next value. 4 minus 1 over 10. The answer is 3 over 10. And finally, 5 minus 1 over 10. The answer is 4 over 10. This is how the probability distribution will look like. We can add all these values in order to be sure of the answer. So, 0 plus 1 over 10 plus 2 over 10 plus 3 over 10 plus 4 over 10. The common denominator is 10. 0 plus 1 plus 2 plus 3 plus 4 is 10. So 10 over 10 is 1. That means this is the correct probability distribution. Let's move to the next exercise. The random variable capital X has a probability function which will be in this form. Kx when x is equal to 1 and 3, k times x minus 1 when x is equal to 2 and 4, where k is constant. Part A, find the value of k. We will start by converting the probability function into a probability distribution. The values of x are 1, 2, 3, 4. Now we will write the probability for the values of x, 1, and 3. So we will look at 1 and 3. It is k times x. So 1 times k, here we write 1k, and we have 3 times k, so 3k. Now for the 2 and the 4. The probability here is k times x minus 1. We write k. X minus 1 means the value of x minus 1. So 2 minus 1, we have 1k. And finally, 4 minus 1 is 3 times k, so 3k. This is the probability distribution. For x equals to 1, the probability is 1k. For x equals to 2, the probability is 1k. For x equals to 3, the probability is 3k. And finally, for x equals to 4, the probability is 3k. Now we need to find the constant, which is k. We will use the property that the summation for the probability of capital X equals to x, or summation for small p of x equals to 1. So probability of x is 1 plus probability when x is 2 plus probability when x is 3 plus probability when x is 4. All of this is equal to 1. Probability of 1 is k plus probability of 2 is k plus probability of 3 is 3k plus probability of 4 is 3k. All of this is equal to 1. When k has no number, it means we have 1. So 1 plus 1 plus 3 plus 3. That means 8k is equal to 1. Therefore, k is equal to 1 over 8. We can leave it in the form of a fraction, or we can change it into a decimal, which is 0.125. Now we have finished part A. The constant is equal to 0.125. Now for part B, we will use K in order to draw the probability distribution. We have the below table and we need to substitute the K. Okay, so K is 0.125. That means when we have K only, the answer is 0.125 as it is. However, when we have 3K, that means 3 times 0.125, which is 0.375. This is how the table will look like. In order to be sure of the solution, we will add all the probabilities and the sum will be equal to 1.